Hi, this is Rafiq. Welcome back to my classroom. Today we are going to see inversion operation. Inversion center or the center of inversion is a point inside the molecule from which lines drawn to opposite directions will meet similar points at exactly the same distance. In other words, we can say all the lines joining similar diametrically opposite points will intersect at a point, and this point is the center of symmetry. In terms of Cartesian coordinates, we can say if there is a point having coordinates x, y, z in a molecule possessing a center of symmetry, there should be a similar point having coordinates minus x, minus y, minus z, which is diametrically opposite point. So in this figure, let it be any molecule of this kind of symmetry. This is the center of inversion or center of symmetry. When you look into the molecule, you will see a point. If you take any of the point, for example this point, which is denoted by 1, you will see a similar point at the exact opposite direction to this center here, the same point. In this way, if you look into any other point in the molecule, you will see an exact similar point at the exact opposite distance to this center of inversion. Such molecules possess a center of inversion. So what we do in inversion operation is that you have to invert every point in the molecule with this center of inversion. For example, when you do inversion operation on this molecule, you have to invert every point in the molecule to the opposite direction like this. 1 is inverted to here and 6 is inverted to here, 5 is inverted to here and 3 is inverted to here, 4 is inverted to here and 2 is inverted to here. That is the new image you got here. And these two images are indistinguishable and they are not identical. So you can say that there is an inversion operation possible, or the molecule possesses a center of symmetry or center of inversion, and that is the point denoted here. And center of symmetry or inversion operation is denoted by the letters small letter I. You see this molecule, let it be trans 1,2-dichloroethylene. Trans 1,2-dichloroethylene. If you imagine a point here at the center of this carbon-carbon double bond, this center, if you invert the molecule through this center, A will go to the position of C, and C will come here, and this hydrogen B will come here to the position of hydrogen D, and D will go here, and these two carbons E and F also will invert their position. New image, and these two images are indistinguishable, and you can say there is a inversion center possible in the trans 1,2-dichloroethylene. So this is the inversion operation. You are actually inverting all the points in the molecule. Let me take you to the website for a moment. If you take benzene molecule, the inversion center is, this is the inversion center, and when you invert this, you see all the points will be inverted exactly to the opposite direction. Okay, I hope it's clear. You see difluorodiazine. Next molecule is difluorodiazine. Yeah, see here, difluorodiazine. In this molecule, this inversion center is this is the inversion center. You see, all the points in the molecules are inverted, and you get a new image that is indistinguishable from the initial one, and so that's a inversion center difluorodiazine. And to take a XCF4 or PTCl42 minus a square planar molecule, this will be the inversion center. You can invert this atom to here, and this to here, this to here, and this to here. So that's inversion center. The next operation is identity operation or identity operator E. Identity operation is an operation which leaves the molecule unchanged. It's actually a doing nothing operation. You just leave the molecule and the molecule remains the same. So every molecule or every object has at least one symmetry element E or identity. So every molecule has a symmetry on its own, and that is represented by the letter E, symmetry operation E. So it's you will think that it's superfluous because you are leaving the molecule as such, and you say there is a symmetry operation. But mathematically, it is very relevant. That's why we are taking it as an operation, identity operation. And that is represented by the letter E. So every molecule has at least one symmetry element possible, that is E. So let me take you to some more details to the E. When you perform inversion operation 2 times, the molecule which we have seen now, trans 1,2-dichloroethylene, when you do an I, you get this image. If you do I once again, that is I into I, successive performance of 2 operations, I into I, you get the initial image again. So when you perform first I, you get this. When you perform second I on this, you get this initial image. So I into I, or I square is equal to I 2 times is equal to E. I 2 times is equal to E. In the same way, when you perform SC3 on this molecule, you get this image. And next C3, you get this. If you perform one more C3, third C3, you get this image. So C3 into C3 into C3, C3 3 times is equal to E. So in general, you can say E is equal to Cn raised to n, Cn raised to n, or Cn n times is equal to E. In the case of reflection, when you this is water molecule, for example, you have a plane of symmetry sigma v, which is bisecting the molecules as represented here. And when you perform first sigma, you get this. If you perform next again one more sigma on this, you get this image, that is equal to E. So sigma into sigma is equal to sigma square, or sigma 2 times, that is equal to E. You can also kindly note that when you perform 2 successive operations, you actually start from the right side. This is your first operation and this is your second operation. In this case, this is your first operation, this is your second operation, and this is your third operation. As per the convention, we start the first operation from the right side. Here, this I is the first operation and this is the second operation. So I hope the operators, inversion center and inversion operation and the identity operation are clear for you. Thank you. Now we have discussed all the 5 symmetry elements in detail, and I hope that you are clear with this topic. Thank you.